Okay. All right, let's get started. Welcome, everyone. This is Getting Started with LaTeX. My name is Eric Shares. I am an engineering librarian here at Parks Library, and I'll be your instructor for the session today. My background is I graduated from Iowa State in 2005 with a bachelor's degree in electrical engineering, and then I worked for 10 years at Intel in Portland, Oregon, and then came back to Ames and Iowa State in 2015, so almost 3 years ago now. And so my contact information is listed here on the first slide. I'll send these slides out to you as long as I can, either you're signed up or I can read your name on the sign-up sheet. I can look you up in the directory and send these out, so you don't have to madly scramble to write everything down. I will say up front that I'm happy to answer any questions as we go along. If you come up with something after the session, feel free to email me or get a hold of me. But I will say that even though I'm teaching this session today, I am not what I would consider a LaTeX expert. On a scale of 1 to 10, I'm maybe a 3. So I know how to do everything in here and a little bit more, but I'm not by any means, again, the sole font of knowledge here, bestowing my wisdom upon you all. So if you want to ask a question today to try to stump me, it'll probably be fairly easy for you to do that. What my goal today is just to introduce you to LaTeX, describe what it is, maybe why you might want to use it, and then show you a few shortcuts to get started. It does have a fairly steep learning curve, I would consider, but I want to show you some things that maybe will get you up and running and writing in LaTeX quickly. That's my goal, as we'll be doing. Can you sign in, please? My goal is to get you started writing LaTeX pretty fast, and you can kind of follow along and write and experiment a little bit as we go along today. So that's kind of my goal. I'm not going to be able to turn you into LaTeX experts, but I will walk you through what I have today and then show you a list of resources that you can choose to go down and deepen your own understanding. The thing with LaTeX is you can go as far as you want with LaTeX. LaTeX will take you as far as you need to go. You can fall down a rabbit hole online pretty quickly with LaTeX. It's almost infinite, the amount of things you can do with it. And so again, I'm not going to be able to distill everything that's possible, but I want to at least get you started, get you understanding some of the major things you can do, and then set you on your way. All right. So today, the introduction. So basically, I introduced myself. I don't think we'll have time to go around and introduce each other, but I want to basically introduce what is LaTeX. What is this thing? Why does it look like that? Why is it called that? And then talk about why you might want to use LaTeX. So I guess I didn't mention, so the middle screen is my slides. Everyone can at least see it. That confuses people sometimes. But so why might you want to use LaTeX? So this is an example of a real LaTeX document that I borrowed from a professor in EE and agronomy named Brian Hornbuckle. He's the one who kind of introduced me to LaTeX and came and gave me a demonstration and showed me a few things. He's much more advanced than I am. But so this is what a LaTeX document looks like. Right, it's all plain text. It has markup language scattered throughout here that tells LaTeX how to format it. And then you run it through LaTeX, and it turns into this. Now, that's a real example. So that's the actual source code behind that paper. This set of characters turns into this. And I think it's pretty powerful. So we'll talk about why you might want to use it and how to get started. And then I saw quite a few of you were looking already at Overleaf. I don't know if you've heard of Overleaf already before. It was on the slide, but Overleaf is a really quick way to get started with LaTeX. Get up and running fast. It's a real-time online editor, so there are some definite advantages to that. There are some drawbacks as well that I'll talk about, but I think it's the simplest way to get us all up and running as quickly as possible. All right. So what is LaTeX, and why does it look like that? So first of all, LaTeX is not pronounced latex. It's not the stretchy plastic material. The X, or the final character in there, is the chi, the Greek chi. So if you're familiar with physics, the field of physics, or the papers that when they put their papers up in the archive, arxiv.org, that X is also the chi, so archive. And so it's similar here. So LaTeX, 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 something like that. That's how it's intended to be pronounced. And so LaTeX is a document preparation and markup language. So what does that mean? So if I wanted to write this line here. The rain in Spain falls mainly on the plain. I want mainly to be in italics and plain to be boldface. The underlying commands I would have to give in LaTeX are \emph for emphasis, and then I do this curly bracket and put in the words or the content that I want that formatting to apply to. And similar for the bold or text BF, text boldface. There's some argument on what's the best way to use, what's the best way to make something bold. There's some disagreement on that, but this will work, text BF, and again the curly bracket and the content that you want that formatting to apply to. Okay. And so LaTeX is often, as I'm sure you may probably know, used in academia quite frequently to write scientific journal articles, peer-reviewed articles, theses, dissertations. This is used mostly, or more often, I should say, in math, science, physics, engineering, statistics, although it is becoming more and more used more widely across campus, I think. So some major advantages of LaTeX. So it formats documents very well, especially math. And so this will render math equations, complicated math expressions very elegantly, very easily, as long as you tell it what you want it to do. This is open source. It's free. It's free as in no money, and it's free as in open source. So it's created by scientists. It was created like back in the 80s, 1985, 1982, something like that, and then has been built upon that foundation as we go on. And again, you can get into long rabbit holes online of trying to decide which one's the best way to use it, or people arguing over how this is intended to be used. But there's a loyal and wide following online. If you Google anything on LaTeX, you'll find these message boards and people going back and forth and kind of having a discussion on what's the best and most efficient way to accomplish something in LaTeX. And then there's many packages, and I'll talk about what packages means. But you can take LaTeX, what you learned today, and extend it to do whatever you're trying to do. So there are ways you can make presentations in LaTeX. This is PowerPoint that I used. You can make slides, exams, books, spreadsheets, presentations, anything you want in LaTeX, as long as you can identify which package you need to load and have it behave the way you want it to. Okay. As for why does it look like that, I don't really know. The official way it's supposed to look is this here, with kind of the superscript A and the subscript E, and I think that's just intended to to show you that it's not latex, it's not the plastic material, and also to kind of show off what it can do. So if you go into Overleaf and type \LaTeX, it'll render it like this, kind of the fancy way. But if you are not able to do that, the capital T and the capital X or chi is how they want you to say it. They want you to write it. All right. So going into LaTeX does require a shift in thinking. And so I use Word mostly. So Microsoft Word and Google Docs are, or OpenOffice is an example of a WYSIWYG editor. What you see is what you get editor. So you do the content and the formatting on the screen, and the way it looks on the screen is the way it's going to look in the final output. When you print it off, that's how it looks. Okay. So if you want to bold something, you double click it or you highlight that piece of text. You click Command B or Control B, or you go through a bunch of menus and you decide which formatting you want to apply to that text. So what you see is what you get. LaTeX is a what you see is what you mean. So you need to describe what it is and not how it looks in LaTeX. So in LaTeX, we write in a plain text, so like a notepad or just a plain raw text editor, and you scatter, again, this markup language, these commands throughout the document. Then you run it through LaTeX, and LaTeX will apply that formatting to your content according to how you set it up. So one of the major advantages of LaTeX is that it frees you from how it looks, and you can focus more on the content. You don't have to worry about formatting the text as you're writing it. You focus on the content, and then you decide how to format it later. So LaTeX will take care of all the formatting for you. Okay, LaTeX is very powerful. Let it do what it does best, and you focus on what humans do best, which is creating the content and describing your experiment or your scientific research. Okay, so it does require a bit of a shift in thinking. Now, LaTeX is open source. There are two major ways to get LaTeX. You can download it for free. You can install it on your local machine, on your laptop, on your desktop, and run it through the command line. So you can install all these packages in LaTeX. You can write your plain text file. You close it, you save it, go to the command line, type LaTeX, then in this example, myfile01.text, hit return, you get a whole bunch of matrix style output. You maybe run into an error, you have to go back to your plain text file, fix it, run it through again. It finally finishes, it produces this kind of temporary file, and you have to turn that into a PDF, and then you can finally open it up and see what the final format would look like. You are free to do this. I did this. I signed up for 2 straight days of debugging and headaches, and I didn't really enjoy it that much. It's basically a computer science exercise. And there's no way for me to get us all up and running using this method right here today. Okay, it's not going to happen. So what I think is better and easier and really lessens that learning curve is to use Overleaf. So Overleaf is a free text editor. I am not a paid representative of Overleaf. I just think it's a handy thing. There used to be 3 or 4 of these things, and they all have kind of merged and bought out, and they're all kind of consolidating around Overleaf is the sense that I get. But Overleaf is, again, a free online text editor that will compile your LaTeX code in real time. So this is an example of some Overleaf code. So you have all the LaTeX commands and everything over here on the left, and you have this vertical bar, and the result or the effect of those commands update in real time, maybe a 5-second lag, and it shows you what is going to happen to your content. Okay, I think it's pretty slick. So instead of running through the command line, getting this, having to convert that into a PDF and all this stuff, you can immediately see the effects of your edits. You're not going to have to sign up for an account today. I hope I have it set up so that we can just jump right into it, just kind of a test account. If you do choose to sign up for it later, I would ask you use your istate.edu email address to sign up. It will get you some slight extras, but then we're also talking about getting a site-wide license to Overleaf, although it's fairly expensive, and with the budget the way it is, it probably won't happen this year. But if it were to happen, then anyone with an istate.edu email would get upgraded to a bunch of more stuff. We can also demonstrate that a lot of people on campus are using it because we can just search for the istate.edu suffix and say, oh, 300 people have Overleaf accounts already or whatever. So my plan is today you don't need to sign up for one. You can choose to if you'd like to later on. All right, questions so far before we get into actually writing some things. Okay. All right, so I would like you to open an example document in Overleaf, and I hope this works. If you just go to bit.ly, so I just made a shortened URL, bit.ly/isu-latex-example. Oops, sorry, go back. And that should open up, so just open up any browser window, Google Chrome or Microsoft Edge or Firefox or whatever. Do this bit.ly/isu-latex-example. That should open up just a very basic document on there. It worked on my machine. Okay, you got it? All right, good. And it did not ask you for your login or anything. Good, okay. So this is just, so before I go on, as we go through the slides, I welcome you to try out things in this Overleaf example. We'll open 2 or 3 of these other ones as we go on today. But I really do want you to try them out as we go. I'll explain a new thing. You can try it out. You can try to break it, leave a typo in there, see what happens, and go on. So I would like this to be interactive. I'd like you to try to apply it because I think that's how I, at least, learn best. So I really do want you to try it out as we go. Did anybody not get in? It worked for everybody? Good. Sweet. All right. So I think what you have in front of you is the bare minimum for a LaTeX document. And so you'll notice commands are starting with a backslash. So another good thing about Overleaf is it'll color code those common commands. So it should be in green. So a backslash will be the beginning of a command. First thing we have to do is declare a document class. So I do backslash document class, and I have curly brackets, and I have to define which class of document there is. I tried to look for an exhaustive list of all the possibilities here. I wasn't able to find one. I got to 50, and I just gave up because people were arguing about, this is the same thing as that. There's article, there's report, there's slides, there's book, there's all kinds of stuff. Article is pretty basic one to start with. Article has sections and subsections. So there are no chapters in article. If you want to write something with chapters, a much longer thing, that would be book instead of article. But basically the document class is kind of a package of formatting rules that is going to apply to whatever content you're going to start writing. So So different classes have different things available to you. But article is generally a good one to start with. So I have the command. So anything that's a backslash and in green is called a command. And then the argument is inside these curly braces. So again, we chose to specify article here. Then the other thing you might notice is the percent sign. So the percent sign will start a comment, and that just means that LaTeX will ignore anything after that comment on that line. So you can insert little comments to yourself. You can take out a line of code, but if you don't want to delete it because you might want to put it back in later, you can just comment it out. If you're familiar with any other programming language, I don't assume that you are. I don't assume any prior knowledge coming in. But if you happen to be familiar with another programming language, they most all will have some sort of way to put in a comment, either double backslash or percent sign or something. But again, a comment is just something that really is more for human eyes, and LaTeX will just ignore that. So you can leave in little notes to yourself. All right, so you type your text between the begin document and the end document commands. And so that's where your text goes. Right now it says hello world. Yeah. So you can type something else in there. For the most part, you just type normally. So words are separated by spaces. Paragraphs have a blank line in between them, so you can kind of force a page break. You can type something in there, see how fast it updates. Space in the raw text is collapsed in the output, so you can put a bunch of spaces in between your words, but LaTeX will ignore those and just kind of condense them down. If you want spaces in between your words, there's other ways to do that than just hitting spacebar a bunch. There are a few caveats. So quotes are a bit tricky. So quotation marks. So the quotation mark next to your enter key, that shift quote, that double quote right there, will always only format as the right-hand pair. And so they'll be going in to the left, toward the end of the word. So if you want, so you can see in this example, I wanted to type in quotes, and I put that double quote on both sides. You can see here how it formats. If I can do this. Yeah, nice. See here, it formats the wrong way. Okay, so the double quotes next to your enter key on your keyboard is always going to format as this right-hand one. So if you want to get the left-hand one correct, you have to use the back tick, which is up here next to the number 1 in the top left of your keyboard. So put 2 of those in there. So I did that here next to hello world, and you can see that it formats it correctly there. Okay. So that's the first of many little quirks or subtleties that you'll run across in LaTeX. Another one is that some characters already have a predefined special meaning in LaTeX. And so if you want those characters to show up in your content, you have to what's called escape those characters. So for example, the percent sign, the hash sign, ampersand, dollar sign, these are already defined in LaTeX as something special. And so if you want that to show up, you have to escape it by putting a backslash before it. So like this. So if you wanted to say 50% of us do something, you have to write 50 backslash percent. And that tells LaTeX, don't treat it as what you normally see the percent sign as. Treat it as just a raw character. Okay. So these characters are already predefined as a function in LaTeX. If you want them to show up, you have to escape them. All right. So errors. So LaTeX will get confused if it's trying to compile something and it runs across an error. And if it does, it'll stop and it won't do anything until you fix that error. It won't give you any output. So for example, if you're trying to put something in italics using the emph command, and you do a typo and mistype it as meph, LaTeX will stop right there because that's not a command it knows. It'll say, hey, hang on, I don't know what Eric meant by that, so I'm going to stop and highlight. I think Overleaf will highlight it in red, and it'll tell you there's an error here. I can't go on. I can't compile that until you fix that error. So errors will happen. Errors are a fact of life in LaTeX. You're going to make errors. If you're a perfectionist, this is not the place for you. But fix them as soon as you see them. If everything was fine and you added one line, now you have an error, you have a pretty good idea of where that error is coming from, right? If there are multiple errors, usually best practice is to start at the top and work your way down, because Overleaf will highlight a line and say there's an error here, but oftentimes the real error is one or multiple lines above where Overleaf is telling you to look. So you kind of have to be aware, slow down, pay attention to what you're doing, and try to figure it out. So let's do an example. So here is a block of text taken from Wikipedia. If you go to bit.ly/isu-latex-ex1 for example 1, this will load a new overleaf instance with that text already typed in there. And I want you to figure out where all the errors are and try to get it to compile completely. So I'll give you a couple minutes to do that. Everybody at least get into it? Did it work? Okay, good. Again, it all worked on my machine, but I didn't know if 15 of us trying to do it at the same time would break it somehow. Yeah.
So that thing needs always to be connected to the internet?
Yeah, so that's one downside of Overleaf is, yeah, it has to have an internet connection to work. Yep, that's true. Yep, because it has to live update. Mm-hmm. Yep, you're right. I forgot to mention that is a downside. You got it? No, you're done. Got it? Okay. Everybody still working? Before I go on, you got it? Okay. So everybody caught the dollar signs. You have to escape the dollar signs. There's 3 of those sprinkled throughout. Right? You caught the percent. You have to escape the percent. And you caught the double quotes. So you can't use, you can't use the double quotes right there. You have to use those 2 backticks to properly format this quotation right here. I liked when I did that. This one right here. Questions? Pretty easy. Saw how Overleaf works. Tells you where there's an error. All right, onward. So we had to escape those 3 dollar signs because, again, those are special. Those are special characters. LaTeX already has reserved those for something else. So why are dollar signs special? What are they reserved for? So LaTeX uses them to mark mathematics in the text. So you could type your mathematical expressions just like this, just in raw text. Let a and b be blah, blah, blah. Let c equal a minus b plus 1. And that works okay. But if you surround your math by these dollar signs, so you have one opening dollar sign and one closing dollar sign, now you can see those are formatted a little differently. So those are in italics. Okay? This example maybe isn't super important, but once we start getting into more difficult things, you're definitely going to need to break the mathematics away from the text. Right? If I wanted to do the quadratic formula, I couldn't really do that here. Okay? So always use dollar signs in pairs. So one to start the math, one to end the math. And LaTeX will handle spacing within the dollar sign automatically. So these 2 things are equivalent. So let y equal mx plus b or y equal mx plus b with a bunch of spaces in it. They both are going to format the same. Okay. But I want you to take away from this slide is the dollar signs mean this is a math expression. Okay. And you have to always start and end around your math expression with the dollar signs. And that's what LaTeX thinks the dollar signs always are. So if you want it to show up as a real dollar sign, that's why you have to escape it. Okay, more math. So you use superscripts is the caret here, so the shift 6. And a subscript is the underscore, or the shift, whatever that is, next to the 0. So here, I see again, we have the bracketed by the dollar signs here. Y, c sub 2, x squared, c sub 1, times x, c sub 0, so on. If I wanted to group those subscripts and superscripts, you can use curly braces to group them. So in this example, f sub n minus 1, it doesn't know that I intended that minus 1 to be part of the subscript, and so it broke it out and just put it on the main line. If I wanted to group it, you can group it around with curly braces. Okay? So you can start to group, sub, and super. And there are commands for common Greek letters or common notation. So again, within this $ environment, so within the opening and closing $, I can do a command /mu, /omega, /small omega. So you notice this omega and this omega are different. It's a capital. This is a small. So I get this or this. Okay, mu, alpha, beta, all those things are already predefined in there. I think Overleaf should, if you start typing BE, it should jump up with, try to fill in maybe beta, maybe whatever else is in there. But those common mathematical notations, Greek letters, things like that are already in there and defined for you. Yeah?
If I want to start a new line, how do I instruct LaTeX to do so?
So you can just put in an empty line here.
Okay.
Yep.
Okay.
That should pop it down.
Oh,
Yeah.
okay.
But I think that was a great question because, one more slide. I have something specifically on that. So you can't put a new line, well, hang on, just 1 second. So I think I got here. So yeah, the common Greek letters, mu, alpha, beta, it's all in there. And capital and uppercase and lowercase as well. Okay? Now, if it's big and scary, put it on its own line by doing the begin and end equation commands. So if I wanted to format this quadratic formula here, I don't want to put all that in the $ environment. I want to do begin equation and end equation. Okay, and you'll see that sets it off, puts it on its new line, numbers it, gives it a number here, right? So there presumably was a formula above this somewhere in my document. But then you'll see I also chose to use the $ notation here to get A, B, and C to show up. So you might notice the fraction command. So the /frac is given as fraction with a numerator in the first set of curly brackets and denominator in the second set. So x equals all this stuff, right, is on the top, and all this stuff is on the bottom because it's the second set of curly braces. You might see this /pm for the /plus minus, or for the plus minus, I'm sorry. /square root will get you the square root sign, and you tell me what's supposed to be under the square root sign. So b caret 2, so b squared minus 4ac. Okay, these are some common commands: fraction, or frac, square root, so on. But this is all inside the equation environment. And now to your question. So LaTeX can handle blank lines in your text, but LaTeX cannot handle blank lines within a math block. So this caused me a great deal of pain as I was trying to put these slides together and doing it kind of alongside an Overleaf. If you put a blank line after this 2a and just hit return and put a blank line in between right here, you'll get all kinds of errors. It'll freak out. You can't put blank lines within your equation blocks. And that is easy to forget, I think, because I kind of like to space things out and see how it's all going. But within that mathematics, or that equation block, you can't have a blank line. Mm-hmm.
What's the
/LDOTS is L dots, so that's just going to get you kind of these 3 ellipses dots. Yeah. Yep. Good question. I didn't say that. Other questions here? This kind of introduces the begin and end equation idea. And I'll take that farther now. So the equation is an environment. So environment is a very loaded term, a very, very key term within LaTeX. So you hear people talking about environments a lot. So a command can produce different output depending on which environment it's in. So I go back here, again, oops, sorry. I don't know how to erase these things. That's going to bother me. All right, let's just clear all this stuff out. So this right here, so this begin and end equation. So now I've started an environment called the equation environment and ended the equation environment. All right? Stop it. So the same command will produce different output depending on which environment it's wrapped in. So in this example, you can see I've got this and this are the exact same things. These are formatting slightly different though, even though I'm using the same commands to call them, to write it. And that's because they're in two different environments. This top one is just within the $ environment, where I just have an opening and closing $. The second one is within the equation environment, where I've wrapped it in a begin and end equation. So you can see the omega, or the sigma is bigger down here inside the equation environment. You can see the subscripts and the superscripts are in different places. And that's just because I've wrapped it in a begin and end equation. I didn't do anything else different. It's the exact same set of code. It's just in a different environment. Okay? I apologize for saying the word environment so much, but it's a very key concept within LaTeX. So even though we use the same commands, it comes out differently because I've wrapped it in an equation environment. Make sense?
Does the uppercase and lowercase for the omega, does that, because it gives you uppercase omega?
Yep, so this is the uppercase omega, and this is the lowercase omega here. Yep. Yep, so they're both defined. I assume there's uppercase alpha and lowercase alpha and so on, yeah. So just to belabor the point, two more environments that will give you different output, even though the same commands are within them. So there's the itemize environment and the enumerate environment. So inside both, I'm just saying item, right? But inside the itemize environment, I get bullets, and there are ways you can specify which bullet you want, which bullet type you want, which color, all this stuff. Inside the enumerate environment, the same item command will get me numbers, and there are ways you can start the numbering at different starting points and so on. But the same command, the same item command, gives me different output because they're inside different environments. Does that make sense? You can tell an environment because you have a begin and an end command that calls and closes that environment. Okay. So another common word is a package. So all the commands and all the environments that we've seen so far come built in with LaTeX, are standard in LaTeX, and are already built in and included inside a standard load of LaTeX. Okay. But if you want extra commands or environments, you can load those using something called a package. And there are thousands of packages out there. Whatever your discipline or major or specialty is, there's probably a set of packages that have commands and environments that are kind of specific to that discipline, or those papers that you'll probably commonly writing. And so if you want to load a new package, we have to use the use package command, and we put that in the preamble. And the preamble is just a phrase that means everything before the begin document. Okay. And so in this example, we'll load the AMS Math package from the American Mathematical Society. So if you're a math person or a statistics person, this might be a package that would interest you. Even if you're not, you may want to use some of these things. But you can see I put use package, curly brace, AMS Math in the preamble, which is before the begin document. So you can try that out. Actually, please do, because I'm going to do something on the next slide that depends on you having loaded the AMS package. So you can try to put a typo in there, put AM Math, and it'll give you an error. It says that's not a package that I know about, and so on. You can load multiple packages. So after this, you could do another use package command. I think you can also put commas within the braces and just specify the next package name and so on and so on and so on. I think. But in this example, I just want you to load the AMS Math package, please. And that gives us access to a whole new set of commands and environments now. Now we've loaded a whole new library of new things that we have access to. One of those is the unnumbered equation. So if you remember over here, I had like a 1 like this, right? Say I didn't want that. Say I don't want that. Here, I can now use equation star. The equation star environment means an unnumbered equation. So it still sets your equation out from your text, gives it a new set of breathing room, but it won't be numbered. And I only have access to that option because I've loaded AMS Math. Make sense? Okay. Another thing you can do, you can align, AMS math allows you to do, is you can align a set of equations at the equal sign using the align star environment. And this one is a little trickier because it depends on some other stuff within there. So you have to specify the ampersand will tell you where you want everything to line up. So the ampersand separates the left column from the right column. And this double backslash here tells you to start a new line. But you can line up a bunch of things on the equal sign as well. Okay. So the AMS math package will give you access to new commands, new environments that aren't standard. All right, let's do another exercise, please. So I'd like you to typeset this whole thing in LaTeX. So if you go to bit.ly/isu-latex-ex2 for example 2, that'll load a new overleaf window with all the words typed in there, and then you can go through and debug it and see if you can figure out how to get it to show properly.
Overleaf account.
Okay.
How do I save your examples that I get from there in my personal account?
Yeah, so it should be saved already.
Because
Yeah.
if I look at projects, they save.
Well, but if you go back to your name,
Uh-huh.
My Projects,
Yeah.
that should kick you out to the main screen. So these are two untitled. These are your projects you must have just started.
So these would be the stuff you said.
It could be. I'm not sure. The other way you can do it is just open it and just copy it into.
Yeah, I think
yeah,
that
works.
Okay, sounds good.
Yeah.
2 minutes ago.
Yeah, so it'll load up all your.
Sounds good.
Yeah. Okay. So see if you can get that to format. You can drag that vertical bar left and right, and that'll kind of zoom in a little bit for you if you want. That bar is movable. Okay. Got it? can't see it. Can you make it bigger? This is drag. You're on share LaTeX. One. Okay. Go back. You got. So you don't have AMS math loaded, so equation star won't work. Yeah. Although I thought it would give you an error. It wouldn't even recognize what equation star is. Slash use package. There you go. MS. There you go. Yeah. Cool. Yep. So you had share LaTeX before. They merged, so share LaTeX and Overleaf merged in like December or November. So you must have had it. Okay. Yeah. Okay. No, that's fine. Yeah. I actually had both accounts, and then when they merged, I just went to Overleaf. But cool. You okay? Okay. You get the package loaded good? Okay, yeah, no problem. How you guys doing? Oh my.
I'll do it doing then.
Okay, well you could probably be teaching this then, huh?
Art Studio.
Those are, I see.
Yeah.
I don't know how those two things.
This is like a little less complex in LaTeX, but it
Yeah.
does most of the work that I need it for.
Okay.
So,
What's your what's your area? What discipline?
my discipline is computational biology.
Okay.
The nice thing about it is that it can run code alongside.
Yeah. I've tried to learn R twice. I did the Midwest Big Data Summer School, which had like an R afternoon.
Right.
And I was okay right after that, but I've forgotten. That was last summer, so I don't really remember anything in R. But yeah, if you don't, I don't really have like a project that would need it either.
Exactly.
But I use jump more often. How are you doing? Okay, you got it? Yeah, looks good.
I'm catching up.
Good, good.
Just having to Google a couple of things about
Oh, that's good. Yep. Same way. How about you?
I get an error that I'm not sure what
Let's
it
see.
is. It says missing dollar inserted.
So you got.
And to me, missing and inserted is good.
So you've got-
Contradictory to each other.
So you don't have the. Oops, sorry. You don't have the AMS package loaded. First of all, so that's got to go before the begin document.
So this is a load or
Use package, but it has to go before begin document.
Ah.
So you have to go up above that. Yep. And title might also have to go. I don't know. But use package. There you go. Then AMS math.
like this?
Yep.
No S.
AMS math. Yeah, not maths.
Okay.
So
And
that might help. No.
still missing dollar inserted. Doesn't sound first to me. So it doesn't want to have the
This
mu
mu?
with the Greek stuff.
Really?
But I put the
Oh, because mu is not in. You have to put it in dollar signs as well. So
Oh.
put yep before
Like
the, nope before the backslash. Yep. Yes.
This is interesting.
There and then after it too. You have to surround it. There, it's auto. It's refreshing. Oops, sorry. So that worked. So maybe
I
I
don't
have
know
to do
why I
that.
put the dollars there, but
Yeah. So you got the good equation. So you don't need the curlies outside. So here var x1. You don't need the curly there
because it's already
because it's already in the
function,
environment.
yeah.
Yep. And then that one you can take out too.
Okay.
Right.
There's no mu. This is so strange.
Mu. Huh. Let me go back. Let me just see one thing quick, sorry. Yeah, it should just be around with the dollar signs. It should format it. Mu. I've used it before. Yeah.
So, how do I get the subscript? Do I need
You have to try to put it in the dollar signs.
within dollar signs?
So put the whole thing. So put the E. Yeah, try right there. Although you had the begin equation, that should work too.
The begin equation?
Yeah. So then you don't need the dollar signs.
I don't know, for some reason it wasn't working. And I don't want it to be numbered, so I put a
Okay.
star.
Yep.
Oops. Yeah, there we go.
Yep. But then you have to load the AMS Math package as well. So
Above
yep,
here,
above
right?
here. Yep. Right there. Good.
Was it
/ use package.
right?
Yep. Right. Yep.
AMS.
Yep. Math. Right.
Okay.
And that'll at least tell it. Yep. And so that needs to be equation star. Also this one. So you open it with equation star, then close it with equation star.
Okay, but
So that.
how do I get this in subscript? It's still. It's not in subscript.
So this one first, you have to close equation star. Yep. And then you don't need that comma, I don't think.
Well, that's part of the text.
Oh, it's part of text. Okay.
Yeah.
Let's see what it does. Now you're down here. Yeah, so put this either in a dollar sign.
This?
Yep. So the square root is a math equation, so you have to treat it as a math.
So it doesn't need the backslash? Or
It needs the backslash, and
Oh.
you need to denote that it's a mathematical equation with the dollar signs.
Oh,
Or
okay.
the begin equation if you wanted to break it out.
So it's either the begin equation or a dollar sign?
Right, and begin equation will break it out like this,
Okay.
and dollar sign will leave it in line like
In
that.
line, oh, I get
And
it.
so then put your close one. Yep,
Well,
it should be.
For text,
Yeah.
it's just in here.
Yeah, and so then you need a close dollar sign wherever you want your inline thing to stop. Right. Let's see. Yep, and then same thing with sigma here.
So we want it to be like within the currency.
So I would put the whole thing in dollar. Yep, right there. And then sigma, you'll have to escape as
And
well.
put it as backslash sum.
Yeah, you can do that, or backslash. That's going to be the capital. So
Wait,
backslash sum is this. So that's, yeah,
Wait,
backslash sigma. Right.
oh, that's sigma.
That's a
okay.
lowercase. Yep, so there you got it. See?
Oh, I see. Okay. Okay, so this still looks wrong. So I want to fix that. I want the I equals 1 to come down here.
Okay, so that's a subscript.
So I put a,
Right.
okay.
There you go. See?
That's it.
Cool. You're on your way. You got it. Questions? How are we doing here? Let's see. You got the math package loaded. Good. Okay. Yep. You got that around. So dollar signs will get you like inline math, right? And the begin and end equation will get you broken out math. So that's right.
So to drop this, to drop,
This thing, you're going to have to do a begin equation. Yep, right there. Slash, good. Yep. Let's begin, slash begin.
Oh,
It's all right.
and then I have to end it again.
Yep, and then you have to end it, right? Right. And then,
It's in between.
yep, and then you want that to go in between, and then you don't need the dollar signs anymore
Oh, I see.
because you've defined the environment already as a math environment. Oops, and then go. Oh, you copied it, you can just paste it.
Wasn't pasted. I copied something else afterwards.
Oh, did you? Okay.
Yeah. That's a bad one.
So S sub n, good. S sub n, yep, equals, and then you can do a fraction.
Mhm.
Yep. So you're here, I just need, that's good. Then we're ready to do fraction.
Oh, the fraction equation.
Yep, the fraction equation, remember what that one is?
Frac.
Everyone's favorite. And then, yep, you've got your numerator and then your denominator. Yeah, get rid of that. Good. The one on top.
Like this.
Yep, you got it.
Glasses.
You got it. Yeah, you might. Yeah, I don't know how to zoom. You're on your way. You got it.
Any spaces before I do this signal? This isn't crazy.
No.
Oh, so.
Let's see, I think that's a lower signal. So this is actually called sum.
Oh,
Yep. And then you can do the subscript and superscript. You got it. Got it? Did you get it? Okay, great. Got it here. Oh, what is that? I don't know what that is.
It's just filler text, but
Ah, I didn't know that. Cool.
it's not that useful except for when I make the document look long.
Yeah, that's awesome. You know, I always wondered how people did that,
Mhm.
but I assumed they were copying and pasting.
You can do blank documents too, I think, and it has a bunch with weird formatting. Yeah.
Well, you want to teach this next time? I didn't know that. That's awesome.
Read through this document.
Okay. Yeah, nice. Okay, good. I have that. Yep, 139 minutes is kind of a famous one. All right. You doing okay? Yeah.
Can I use the backslash L dots to get
You should be able to, but it has to be in a. Actually, does it have to be in a math environment? Try to put it with dollar sign just around it first. Actually, I don't think it does, but let me see.
my backslash?
You don't.
Whoa, what's happening?
Oh, you got insert on.
Oh,
There
okay.
you go.
Put it with $10.
Yeah. Well, there you had it. So I don't think you do need the dollar signs. Yeah, take that out. Was it not working before? Or you just had, I think you just say slash.
Yeah, it shows error.
Huh. Yeah, it should just be. It's not in a
Yeah,
environment.
that's what I remembered. I was like, why is it
I'm not
square
sure, to be honest.
Also, my underscore hasn't made a subscript here.
The underscore, I think, needs to be in a dollar sign. Yeah, no problem. So let me just, that's pretty much, that was the last thing I had. So far today, you've learned how to typeset in LaTeX, use lots of different commands, handle errors. We've seen lots of errors today on purpose. Format beautiful mathematical equations, use environments, load packages, all this stuff is amazing, right? But I don't have time to take you all the way to the next step. So if you want to keep going, parts 2, so this was actually part 1 of a predefined overleaf class. If you want to keep going with parts 2 and parts 3, you'll learn how to structure documents, how to refer to sections. So if you have, refer to figures also, if you have figure 1 and you start typing in your body, you can see in figure 1, blah, blah. Then you come through and add something before that. Now it's figure 2. You don't have to hunt through and find every instance. It will automatically update all those references for you. Okay, same with sections. If you're referring to this section, section 1, and you decide you don't want it to be section 1 anymore, all that is automatically taken care of. You cross-reference things. I put in tables, how to do citations. I wish I had time for citations. So you don't have to be the one typing in, is it last name, comma, first initial, then parentheses with the year, and italicize this and that. Don't do that all manually. You have a citation file that you refer to. It's /cite, I believe, and then you put a little shortcut, and then it'll bring that citation in. Then you'll load the package that has your citation style. So if you want to switch citation style, you just comment that line out, put in a new line, boom, it updates everything for you. Okay? It does take a little bit of work to set it up that way, but when it works, it's pretty slick. Journal style templates. If you submit a paper to a journal and they say no thanks, and you want to submit it to a different journal, you change one line of code, it formats it completely differently. Again, because we focused on the content and not on the formatting. And so I like to show this. So the difference between these two slides, right, is just one line of code. So all I've done is commented out something in the top left, and you can see it formats completely differently, okay, which I think is pretty powerful. All the content is exactly the same, just LaTeX interprets those commands differently depending on which. So this is journal one column IEEE trans, this is IEEE transactions, which is a journal library or journal family, or just journal IEEE trans. So this is kind of the standard way. If I want to do one column, I change one line, it looks like that. I don't have to go through in Microsoft Word and center this and do all this kind of stuff. I change one line and all the formatting updates for me. So if you want to go on with parts 2 and parts 3, there's the link here. Again, I'll send all this stuff out. I do have a library guide where I collect a lot of these things. That's the link here, just bit.ly/ISU-LaTeX. That'll take you right to the guide. It has my name and my face if you want to get a hold of me again. And I'll put these slides up there. I'll also email the slides to you. All these resources, if you're interested, you can go farther with your knowledge and surpass me probably pretty quickly. The official site of LaTeX is here if you want to download it and put it on your own machine and run it through the command line. If you have a spare month and a half to do that. The not-so-short introduction to LaTeX, or LaTeX 139 minutes, is kind of a famous summary guide. Not really a summary guide. It's pretty in-depth. But it's a freely available PDF. You click this, you go right to it. We have 16 books in the library, both print and ebooks on getting started. I have this one, First Steps in LaTeX, right here that I've checked out. This one, Learning LaTeX. So these are all up in the Z's, Z253. You click this link, it'll run a search in our catalog. It'll show you all the books. Some of them are ebooks, so you don't even have to come here to check them out. And the graduate college template, the LaTeX template for theses and dissertations, which may be of interest to some of you. So you go there and it has the template for you that you can load and start to build your T or D. Other than that, my major advice is what you would have done anyway. Just go to Google, LaTeX help, LaTeX 2 columns, LaTeX this or that. And once again, you can fall down the rabbit hole of all these message boards and long documents and things. But there's a lot of help out there. So that is what I had. We're supposed to go 3 to 4 today, although both those say 3. I'm happy to stick around if you have other questions. If you want to contact me later. Yep. Otherwise, thank you. Fill out those evaluations. They're anonymous. Just leave them on the back table if you would, please. Free to go. Yeah.
So for overleaf, you need to be online, right?
Yeah.
But let's say you have another editor on your computer. Do you need to be online to install some package, or they come pre-installed, something like that?
That's a good question. I don't know.
Yeah.
Yeah, because if it doesn't have the package installed, I think you do need to be online because it must go get it, and then I think it downloads a local copy, and then you can be on the airplane or something and using it. Yeah, I assume you have to have some sort of connection to go out and get it, because I don't think it comes with all 1,000 or so packages loaded in the original distribution. Yeah, yeah. I mean, one of the major downsides of Overleaf is you have to have an internet connection for it to work. But if you're on a plane, you can just type in a plain text file, and then when you get it back, you can load it in there, copy and paste it back in there, and see all your errors. But yeah, I think it's much quicker and faster than
Yeah.
than
just-
installing it on your machine. Yeah.
All right, thank you.
Yeah, no problem.